This is part 2 of our discussion of binomial probabilities. If you haven't already watched the first video, part 1, please do that, because if you do that, this video will make a lot more sense. And the first thing we're going to talk about in this part 2 is what is really going on in a binomial probability problem. And the way we're going to look into that is by using an example. And the example is from the Triola textbook, section 5.3, problem number 29. And here's the problem, and I'll just go ahead and read it. The brand name of Mrs. Fields cookies has a 90% recognition rate. That means that apparently across the whole country, they happen to know, somebody knows, that 90% of everybody recognizes the name of Mrs. Fields cookies. If Mrs. Fields herself wants to verify that rate by beginning with a small sample, and verify, that means she wants to see, is this really true that 90% of everybody recognizes my name in the cookie business? So if she wants to verify that rate by beginning with a small sample of 10 randomly selected consumers, so she's going to go talk to 10 consumers chosen at random. Find the probability that exactly 9 of those 10 consumers recognize her brand name. Also, find the probability that the number who recognize her brand name is not 9. So let's talk about how to think about this problem. If you remember from part 1 of our discussion of binomial probability, I made a big deal out of the fact that whenever you hear the word binomial, you should immediately think NP(x). So we can phrase this problem in terms of NP and x, and we're going to do it this way. Given that the overall probability of a success, and success in this problem is name recognition, is 90%. This is very important. The overall probability of success is 90%. What is the probability that out of 10 trials you will have 9 successes? That is, out of the 10 consumers that she's going to talk to, out of those 10, 9, exactly 9, will recognize the name of Mrs. Fields cookies. So when you think of the problem in these terms, then N is 10, P is 0.9, that is the recognition rate. We've converted the percentage to a decimal, which you have to do, and x equals 9. Every binomial probability problem should be thought of as a table with 2 columns. The first column is all of the possible values of x. And in this case, that means out of those 10 consumers, all of the possible number of those 10 who might have heard of Mrs. Fields. And we'll see that all those possible numbers go from 0 to 10. And the second column is the probability for each of those values of x that actually happens, that x equals each of those values. And we can create this table in our calculator. So we're going to go to the calculator now and create this table in our lists. And the way we're going to do that is we're going to press the Stat key and the Enter key, and that will take us to our lists. And in list 1, we're going to put in all of the possible values of x. Well, again, out of 10 people, it's possible that none of them have heard of Mrs. Fields. So the first number we're going to put in is 0. It's also possible that 1 person has heard of Mrs. Fields. It's also possible that 2 have heard of Mrs. Fields, all the way up to 10. So I'm going to pause this right now while I enter all those numbers. So you can see now in list 1 I have all of the possible values of x. In other words, out of 10 people, all of the possible numbers of those 10 who might have heard of Mrs. Fields. And now we are going to find the probabilities for each of those numbers, and we're going to do it all in one step. And the way we're going to do it is I'm going to put the cursor on the L2, and I'm going to enter a binomial function into the calculator. Second vars, And now I'm going to scroll down to Binomial PDF. Here you see Binomial PDF and Binomial CDF. In this case, we want Binomial PDF, so I'm going to choose that. And what I need now to tell the calculator is N and P. Remember, every binomial probability problem, you should think NPX. For this purpose, we only need to put in N and P. And we see here that N is 10 and P is 0.9. So we're going to put those in here. 10, then I'm going to put a comma, and then I'm going to put 0.9. I'm going to close the parentheses, and I'm going to hit enter. And something wonderful happens when I do that. Here are all of those probabilities. This tells us that the probability that none of those 10 people heard of Mrs. Fields is 1e to the negative 10. We're going to see in a minute what is all this stuff about e to the negative 10 and e to the negative 9. Take my word for it right now, they're very small numbers. Let's go on down here to 5. This says the probability that 5 of those people have heard of Mrs. Fields is 0.00149. Well, the number we were interested in was 9, so let's go down and look at 9. Here, this is 9 people recognize the name of Mrs. Fields, and the probability is 0.38742. Now let's go look back here, and you'll see that I've created this table here. So you'll see here this x, these are just all the values that are in list 1. And this p of x, that means what's the probability of x? So this number right here is the probability that x equals 0. This number is the probability that x equals 1. This number equals the probability that x equals 2, and so on. Down here is 9. That's the one we just looked at. This is the probability that x equals 9. That's 0.38742, which is actually the answer to our question. And here you see this bubble tells us the probability that x equals 9. I'm going to pause now and just talk a little bit about this e to the negative 10, e to the negative 9, all these e's here and what they mean. And it explains it right here. I'm pointing at this one right here. The e negative 4 means you move the decimal point 4 places to the left. So when you do that, 1.4 e to the negative 4, that's this number right here, equals 0.00014. This 1.4 here is the same as this 1.4. But we took this decimal point right here, we moved it 4 places to the left, which put 3 zeros in front of that 1. So here are those 3 zeros. 1, 2, 3 zeros, 1, 4. At any rate, it's a very small number, but you need to know what these e to the negative 10 numbers, how they work. And this explains that. You'll notice here, I also have a bullet that says, or I should say a bubble, that says, what's the probability that x is less than 5? Well, one way we could find that is to look at all of these values of x that are less than 5. That's 0, 1, 2, 3, and 4. And here are the probabilities of each of those possible values of x. If we were to add those up, which we're not going to do right now, we would get the probability that x is less than 5. So I just opened up this paragraph right here, and it basically tells you the same things that I just told you. But let's look at this next thing right here. The problem also asks, what is the probability that the number of people who recognize the name is not 9? Well, this is just the complement, see that word complement, of the first question. This question up here said, what's the probability that x equals 9? We found that that was 0.38742. This is saying, what's the probability that the number of people who recognize the name is not 9? That means, is it 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 10? What's the probability it's any of those? Well, one way to do that would be to take all of those individual probabilities and add them up. But the easier way in this case is, since that's the complement of the first one, is just to subtract the first one from 1. So 1 minus 0.38742 is 0.61258. So that's the answer to that second question. What is the probability that x does not equal 9? Now let's ask a different question. What is the probability that the number of people who recognize the name Mrs. Fields is less than 5? So in terms of notation, we would say, in other words, what is the probability that x is less than 5? One way to answer this question is to take the probabilities that x equals 0, 1, 2, 3, and 4 and add them all up. This is what the blue bubble shows, and I'm just repeating something I mentioned briefly before. So that's one way to answer this question. Let's look at this paragraph down here. It is important to know that these probabilities exist in table form, and you can always find them that way. But there's a faster way to find the probabilities without using the table at all, using any table. We'll see now how to do that on the calculator. We're going to use the calculator to find all of the following problems based on the same Mrs. Fields problem. So here are all these problems we're going to be solving. There's 1, 2, 3, 4, 5 different problems. Find the probability that exactly 9 of the 10 consumers recognize her brand name. Find the probability that fewer than 5 recognize the name. Find the probability that 5 or fewer recognize the name. Notice the difference here. This is very important. Fewer than 5 means 0, 1, 2, 3, or 4. It does not include 5. But if we say 5 or fewer, that includes 5. So now we're talking about 0, 1, 2, 3, 4, or 5. This one says find the probability that more than 7 of the 10 consumers, that means 8, 9, or 10. This one says find the probability that at least 7 of the 10 consumers recognize the name. That would be 7, 8, 9, or 10. So let's go take these one at a time. The first thing I want you to know is how to use notation, because all of your instructors will want you to be able to use this notation. The probability that exactly 9 of the 10 consumers recognize the brand name is written this way: P parentheses x equals 9. And here's how we're going to do that in the calculator. So I'm going to come over here to the calculator. I'm going to clear my screen, and I'm going to do this. Binomial PDF. Notice that P there. We're going to do second vars. We're going to scroll down to Binomial PDF. Oh, I went a little too far. I'm going to choose Binomial PDF, and then I'm going to put in, just like it says here, NPX, 10.9 and 9. 10.9 and 9. Hit enter, and there's our 0.38742. It's the same answer we got when we did it on the table, but you can see in this case you're not using the table at all. You're just going to a blank screen and doing it. By the way, if you have the new operating system, your screen will not look exactly like this screen on your calculator. You will see Binomial PDF at the top, and then it will ask you for the number of trials, and that's going to be 10. It's going to ask you for the percentage, and that's going to be 0.9. And it's going to ask you for x, or the number of successes. Yeah, it won't ask for x. It will ask for the number of successes, and that's going to be 9. So N, P, and X if you have that new operating system. Okay, let's do this next one. Find the probability that fewer than 5 of the 10 consumers recognize the brand name. Well, I'm going to clear our screen first. Here we're going to do Binomial CDF. Notice that this is in red. I want you to always be clear when you're using Binomial CDF and when you're using Binomial PDF. The only time you're going to use Binomial PDF is if you're finding the probability that x equals an exact or a specific number. All the rest of the time, you're going to be using binom CDF. So let's do that. Second, vars. We're going down to binom CDF. And there it is. Enter. And now we're going to hit 10.9 and 4. 10.9 and 4. We're going to hit enter. And there you go. 1.469 e to the negative 4. That means we move the decimal point over 4 places to the left, which is going to give us 3 zeros, then a 1, and then this 4, 6 rounds to a 5. So that's what we have here. I'm going to stop for a minute, and I want to make sure you understand why we put a 4 here. And that involves understanding how binom CDF works. So that's what we're doing here. When you're using binom CDF, entering n and p is exactly the same as with binom PDF. But the tricky part is entering x. So here's an example for the problem we just did. We did binom CDF, so there you see the C. N and P are just like with binom PDF. N is 10, P is 0.9. But then we put 4 in here. Remember the problem said find the probability that fewer than 5 of the consumers. That means 0, 1, 2, 3, or 4. So we put a 4 in here. Note what this says. Binom CDF will always calculate the cumulative probability starting at 0. Binom CDF always starts at 0. You can't see the 0, but I wrote it in here. You can't see that on the calculator. We start at 0 and we go to x, which is the number that you're going to put right here. So binom CDF will calculate the cumulative probability going from 0 to whatever number you put here. And that, in this case, that number is 4 because we're saying less than 5. So that's why we put a 4 there and not a 5. Less than 5. Okay, let's do this third problem. Find the probability that 5 or fewer of the 10 consumers. So now we want to go from 0 all the way up to 5 and including 5. But again, and this is, this is the way the notation looks, the probability that x is less than or equal to 5. That means the same thing as 5 or fewer. So we're going to go to binom CDF, second vars. We're step by step going down to binom CDF. We're going to put in 10 and 0.9 just like we've been doing. But now we're going to put in 5 because we're including 5 here. And there you see 0.0016, and that's our answer, 0.0016. Let's do the fourth question. And this introduces a new complication. So be aware of this. And before we start, I want to remind you, binom CDF will always calculate the cumulative probability starting at 0. Well, you see in this next question, the probability they're asking us for does not start at 0. So we're going to have to add a step. Find the probability that more than 7 of the 10 consumers recognize the brand name. Well, more than 7, that means 8, 9, or 10. Well, that does not start at 0. So what we have to do is to find a probability that we can find on binom CDF, and that is the probability from 0 up to 7. And then if we subtract that from 1, that will give us the probability that x is greater than 7. And this is because I'm going to go up here and look at this table again. It's very important to remember that if we add up, oops, that wasn't supposed to move. If we add up all these probabilities, they must total 1. Okay? So the way we can find this funny probability that x is greater than 7 is to find the probability that x is anywhere from 0 to 7, which is what this will do, and subtract it from 1. I showed us doing this all in one step. You can do it in one step or you can do it in two. So let's go, even though I showed this in one step, let's do it in two first. So we're going to go second vars binom CDF, and now I'm going to put in these values 10, 0.9, and 7. So again, that's the probability that x is anywhere from 0 to 7. But that's not what we want. We want the probability that x is greater than 7. So if we subtract this probability right here from 1, that will give us the probability that x is greater than 7. So I'm going to do 1 minus, and by the way, here's how you can do this. If I hit second answer, it will take 1 minus this most recent number. And that's 0.9298. And there's our 0.9298. Again, you can do it all in one step. Let me clear my screen. You can do 1 minus second vars. Then we're going down to binom CDF. Our 10, our 0.9, and our 7. And there we did it all in one step, 0.9298. For our last problem, and again, it's very similar to this one, but you notice this one says find the probability that at least 7 of the 10 consumers recognize her brand name. Many students are confused by the phrase at least. At least 7 means 7 or more. And here's the notation. What's the probability that x is greater than or equal to 7? That's the same thing as 7 or more. That's the same thing as at least 7. Again, because this probability does not start at 0, it starts above 0, we have to do this two-step process. So I'm going to go ahead and do it like this. 1 minus, but notice here what we put in for x is 6. We put in 7 here, we put in 6 here, because we're finding the probability that x is greater than or equal to 7. To find that, we're going to have to first find the complement, which is that x is less than 7, and that's why we're ending at 6. Second vars, I want to do 1 minus. 1 minus second vars. .9 and 6. And there's our answer, 0.9872. I realize that this is confusing. I really encourage you, listen to this presentation of this problem several times, and I think once you've done that a few times, you'll start to get the idea, especially about this 1 minus business. The first time you see it, it very well may not make sense. But go through it a few times, and I think it'll start becoming clear for you. So that is the end of this presentation.